Hey, welcome back to our triangle similarity video series. We're looking at the triangle proportionality theorems. There's the angle bisector problems. There's these problems that are the parallel sides or the parallel lines to the base. So just as a warm-up here, Clarissa needs to find the distance across a lake in the national park. She locates points A, B, C, D, and E and takes the measurements shown. She thinks she can use similar triangles to find the distance. Okay, so she thinks she can use similar triangles, but are those actually similar? So let's look at AMR and AST. So how could I prove that they are similar? Using angle-angle or side-angle-side or side-side-side. So maybe the first thing we should do, and anytime I see triangles like this that are kind of stacked on top of each other, my first instinct is always to just move it out onto the side. So I always want to just move these around, draw another set of triangles, because that seems to be a good starting point. Okay, what do I know about these triangles? Well, not a whole lot. I know that this angle is shared. Okay, so maybe there's a potential for side-angle-side or for angle-angle. I don't know. But what else do I know? Well, I know that this line is parallel to that line. So now what am I working with if I have those parallel lines? I can look at these parallel lines, and it looks like they're being cut by a transversal. So let me just erase some of this extra stuff that maybe isn't super necessary. Alright, I got parallel lines and they're cut by a transversal. Well, what does that give me? I could use alternate interiors. That doesn't look like it's going to help me. I could use alternate exteriors. That also doesn't look very promising. I could also use corresponding angles. Those angles are corresponding, which means that they must be congruent. So those angles are congruent right there. Well, can I use that in any way to find the other angle? So let's see, I'm going to erase all this stuff. Now this isn't very necessary. Okay. Cut by a transversal, two parallel lines. And look at that. Now I've got another set of corresponding angles. So not only do I have angle-angle similarity, I've got angle-angle-angle similarity, which isn't a real thing. You don't need three angles, but I could find three angles that are corresponding and congruent. So these are similar. I'm going to use angle-angle to show that these are similar triangles. Okay, so what in the world could I do to find the missing side for the lake? Well, there's a nice shortcut. I could do 6.5 and then figure out what this is. 6.5 plus 12, 18.5, and then 8, and then whatever this is. And then after I find that whole side length, that is this side right here, after I find that whole side length, I could subtract the 8 to get just the part I want for the lake. But there's also a shortcut that we're going to work with today. So I can take 8 over the lake. I don't know what the lake is yet. That's x. Equals 6.5 over 12. Those corresponding parts, because 6.5 would correspond with 12, and 8 would correspond with the lake. So that's a shortcut that I could use, and a quick way that I always like to do when I'm doing these problems to remind myself which way to divide, whether it's an angle bisector or a parallel line. I kind of bold it or shade it in or highlight it or whatever, and it almost looks like a division bar where you can see 6.5 is being divided by 12 and 8 is being divided by the lake. So 6.5 over 12, 8 divided by the lake, and then cross multiply and solve. So 96 equals 6.5x. I'm not sure what that would be. Give me a second. 14.77. So that would be 14.77 kilometers wide. It looks like if I cross multiplied and solved. All right, so let's take a couple more looks at some practice problems to see if we can identify some missing pieces. Well, AM is 12, AR is 20, MS is 16. How could I find RT? Again, I always kind of like to make my division bar by highlighting that parallel line in the middle. And then it looks like I've already got my two fractions. 12 over 16 and 20 over x. I have no idea what x is. But 12 over 16 equals 20 over x, or 12x is going to be equal to, that's 200 plus 120 is 320. And then you could just divide, and it looks like that would get you RT equals 26.7 or 26.6 repeating, approximately. All right, I'm going to give you guys a chance to try the next practice problem, but that theorem that we're working with today says that if a line that's parallel to the base, that's the key here, this line must be parallel to the base to get us those corresponding angles for angle-angle similarity. If a line parallel to the base cuts through the triangle, then the sides are cut proportionally. All right, so let's solve for x. I'll give you 4 and 10 and 12 and x. So take a minute, pause the video, and then unpause and check your work. All right, so if you haven't finished yet, you should pause the video and then finish. If you are done, then you got 4 over 10 equals 12 over x, so 120 equals 4x, or x equals 30. So that's how you would solve those parallel line proportionality theorems. You can check back in a couple days for another review of the angle bisector problems. And then just let me know what questions you have. Send me an email, or I will see you in class.